Hi everyone, Vega here, and in today's video I found this rather interesting list of nearest stars by type here on Wikipedia. So I thought we'd have a look at what those are, and let's go through some of the list. I'm not sure how many we'll get through today, be a several part video perhaps. First of all, nearest Sunlike star, so we've got obviously Alpha Centauri A and B in there, as we probably know we're around 4.4 light years away. Interesting here, it says the record was actually held though by 61 Cygni, which, if I remember rightly, a pair of K-type dwarf stars. So that's the reason that 61 Cygni was probably originally thought close size, because it was actually the first star whose parallax was determined. So that was the first star whose distance we knew what it was. Parallax, of course, means, it says here, the apparent shift in position of an object is seen from two different points, not on a straight line. So let's just have a quick look at 61 Cygni, shall we? Which is actually a very interesting binary system. Here we are, 61 Cygni. They have two K dwarfs, and these were the first stars to apparently have their parallax measured. Nearest normal star, I'm not sure what it means all that, but presumably it just means a main sequence star. Alpha Centauri C, of course, approximate 4.2 light years away. I think that's fairly common knowledge, really, isn't it? The sort of distances. What I'd like to find just on this screen is what the Alpha Centauri binary stars look like from Proxima. So let's have a quick look at that. So there's Proxima. So looking away, there's the binary pairing of Alpha Centauri. Let's just zoom towards it, shall we? There's the huge distances. There's the system there. And of course, Rigel Centaurus is Alpha Centauri again. Let's have a look back then towards Proxima Centauri. It's there, it's not that tiny thing. Proxima Centauri, 0.23 light years away, an apparent magnitude of 4.77, it says there. So even from just that distance, it's barely even visible from in the Alpha Centauri system. There's Rigel Centaurus, of course, and there's the beautiful Tonomen below it. There we are in distance. And so back to our list. Nearest degenerate star, so degenerate being dead star basically, is obviously Sirius B. Quite common knowledge that Sirius B is roughly the same size as the Earth. Let's have a look at this on the space engine. Also known, of course, as the POP. It's the nearest degenerate there is the little tiny white dwarf. Where's the huge Sirius star up there? There's Sirius, look at that in the skies of Sirius B. 20.67 astronomical units, has an apparent magnitude of -23. So roughly the distance of Uranus then to the Sun, and there's the beautiful Sirius. And what a bright star there is. Let's look at that. Capella, and that's Capella there. And how far we'll go, of course. And so we're looking back at this period of time from Sirius B towards Sirius A, and there's Capella. It's quite a nice little scene there, isn't it? Okay, let's bring down the list again. The nearest sub-dwarf is Captain Star. Sub-dwarf being very small, I imagine. Let's have a look at the details of Captain Star. As I'm aware that Captain Star is a very fast-moving star. Let's have a look. So Captain Star, mass of 0.28 solar masses and a radius of 0.29, leading to a luminosity just 0.012 solar luminosities. So there are smaller red dwarf stars than Captain Star. Quite interested to see where it is there. As we see there, obviously the largest star in that vicinity, or the brightest star I should say, is Canopus, Captain Star. So let's have a look on the space engine then. Let's go back to planet Earth, and now let's see if we can find Captain Star and see where is it. That's the question. It's down awesome where. It's the Sun, obviously. And there's Captain Star with a visual magnitude of 885, so clearly out of the possibility of being seen with the naked eye. So roughly like that. Presumably this is Canopus. Yeah, there's Canopus. There's the Large Magellanic Cloud. So Captain Star is somewhere here, and it's moving very fast across the skies, at least in astronomical terms. Yeah, up at 245 kilometers a second. And with a spectral type of M1.5. So let's have a look at Captain Star. Show it's little tiny. I say tiny, but it's an M1 sub-dwarf. So M1 is towards the hotter end of the red dwarf. See what stars there are in the vicinity here. Looking at Captain Star, there's Canopus, of course. What's that bright one there? That's a very bright star, isn't it? That's a procedurally generated planet there. What is procedurally generated? I'm not aware of any planets around Captain Star. Comparison there with Jupiter, so it's not a very big star at all, is it, Captain Star? The nearest sub-dwarf, it says, nearest borderline subgiant. So, is that really a borderline subgiant? It's certainly not the main sequence star, is it? Procyon, it's sort of in the process of leaving the main sequence. You can see there spectral type of F5, 4 to 5. So it is slowly moving off the main sequence and certainly will become a subgiant in the not too distant future. That's Procyon, of course. So then they've gone sort of right on the edge of the category. Let's have a quick look at Procyon. That's probably Procyon B, isn't it? Yeah, the white dwarf companion. That's the beautiful Procyon. It's that red star there as well. Capella again. Capella keeps popping up, doesn't it, on Pollux and the Kiilstofte, isn't it? Yeah, Kiilstofte. So I wonder what the world looks like. Let's have a look back towards the sun from Procyon then. See what, if we were looking from Procyon, what we might see. There's the sun there. The second magnitude star, so relatively bright in the Procyon skies, although not outstandingly bright by any means. There's Altair, so we'll go back towards Achernar. Not really anything obvious. Other than Altair, there's a quite bright one there, isn't there? There's a lot. It's that one, that's Sirius, of course. So, yeah, we've got the sun. It's this one, isn't it? Looking back to the skies of Procyon. There's our sun. And of course, Sirius, which presumably is still the brightest star in the skies of Procyon. Sirius is actually the brightest star in most of the stars in our local area. But from Procyon, look at that apparent magnitude, minus 2.45. Wow, isn't it? That's incredibly bright for Procyon, isn't it? And that's probably because it's not that far, and it's only 5 light years from Procyon. So it's Sirius dominating the skies in the system, Procyon system. Nearest undisputed subgiant. So now we're talking about something that actually is probably a giant star. Delta Pavonis is a G8 subgiant star. Yeah, so yellow star in the Pavonis constellation. And says Delta is 24% brighter than the Sun. It's slightly cooler, with 105% of the Sun's mass. Yeah, so it's not all that really a giant star, is it? It's certainly not a giant anyway. Giant is, even that, to be honest, feels like it's pushing the definition a bit, but it's just my opinion, of course. Of course, Pollux is the nearest true giant star. That's fair. Beta Geminorum, Pollux has got the 3 designation there, so a K0, it's almost a G-type star, quite reasonably hot. And the one thing that's always interesting to look for Pollux is, of course, across to the sister star of Castor, which again is another very bright star. Let's just zoom out a little bit. As there's Pollux, there's Castor, not there with an apparent magnitude of minus 0.8. That's quite dim, actually. To be brighter than that for Pollux. I'm sure that would seem right. Feels like it should be a bit brighter, but anyway. So right in the heart of Gemini here with Pollux. And where's Pollux B? Festias. It might be under Festias. Let's have a look. Well, Pollux B, which is the known planet of Pollux. Pollux, the nearest giant star to us. And there's Pollux B. Should we just speed time a bit? I'm going to put Pollux B orbiting there, and beautiful star of Pollux, Celestias, orbiting around its parent, while Castor in the distance there looks on. I don't know what star that one is. Maybe it's Altair. Elena is actually another very interesting star in Gemini. Let's find Elena while we're in Gemini. And there's Elena, that's Gamma Geminorum, another quite an interesting star. And relatively bright again in the Pollux skies, although not incredibly bright. Let's go on then, shall we, with our list. Nearest red giant, Arcturus. There's actually a list of giant stars here. These are the nearest ones. We've got Pollux, Arcturus, Deneb, Jedi. I'm all that aware that's the star actually. I need perhaps need to have a look at that one. We have a look. Deneb, Jedi in Capricorn, designated as Delta Capricorn, and it's an A-type giant star with a mass of 2 solar masses and a luminosity of 8.5. So quite an interesting star there. Deneb al-Jidi, again, my Arabic pronunciation might not be all that great. Interesting nonetheless. Then the Capella stars, of course. Back to our list, we will look at Arcturus, weren't we? And let's have a look at Arcturus, shall we? Arcturus is a star that's quite interesting in the sense that it's very much like perhaps where our sun is going in the future. It's got some procedurally generated planets as well, possible planetary system. Arcturus exhibited a long period radial velocity oscillation, which could be interpreted as a substellar companion. This substellar object would be nearly 12 times the mass of Jupiter and roughly the same orbital distance as the Earth is from the Sun. Yeah, actually, I think we've talked about that planet before, haven't we? Because obviously, any planet in orbit around Arcturus from the distance of Earth would be toast at this moment. But originally, before Arcturus went red giant, possibly a huge gas giant like that wouldn't necessarily be habitable, but certainly its moons could be. And if we look from Arcturus' skies back towards our sun, it's getting very dim there, isn't it? The apparent magnitude of 5. Yeah, Arcturus is after Sirius and Canopus. Arcturus is actually the third brightest single star in our skies, but really our sun doesn't really compare to Arcturus, does it? Let's zoom away. Arcturus dominating the skies for quite a long way, 37 light years from our sun. Away from Arcturus there, 2.9 light years. So Arcturus until we reach some of these other stars, and the sun's virtually gone completely there. And let's have a look at one more, shall we? The nearest giant is Canopus. Right, that's very interesting, but I've just one more here. The nearest carbon star, that's interesting, isn't it? The CW Leonis is a carbon star. Now, a carbon star, it says here, is a luminous red giant whose atmosphere contains more carbon than oxygen. Okay, so it's not actually strictly speaking made of carbon, it's just it contains more carbon. And this one, CW Leonis, is also a runaway star, so it's one of those ones that's travelling very fast. Let's just hop back to Arcturus, shall we? And again, I was talking about Sirius. I'm quite interested to see what Sirius look like from Arcturus, because they're two of the brightest stars in our local area. They're roughly in the same direction, the star in the sky, not completely, of course, roughly in the same direction. Oh look, Sirius is behind Arcturus there. Let's just go past the star. Still very much getting used to space engine. I'm just trying to find that Sirius popping out, so perhaps if we just go over the top of Arcturus. There's Arcturus at the bottom there. Sirius from Arcturus is 41 light years and apparent magnitude 2. So actually it's starting to get fairly dim. It's definitely not going to be the brightest star in Arcturus skies, that's for certain. I don't know what that would be. Let's just have a quick look for some bright ones showing that little procedurally generated planet there. It's looking not as Muffred. And then number 9 is 2.72. That's very, very bright star, isn't it? That's just the last thing we do. Is Muffred, Betelgeuse. No, it's a G-type subgiant. It's a bit like Procyon then, with a luminosity of 8.78. And Muffred is 37. So yeah, it's in the vicinity of Arcturus. That's why it's so bright. I didn't know that actually. It's quite interesting, isn't it? Arcturus itself is a very bright star, but this Morphrid is almost like a companion. There it is. Let's go to Morphrid and have a look at Arcturus, because it'll probably be even brighter. Oh, it's a binary star. That's interesting. Yellow binars, gem. And we're on that. That presumably is Arcturus there, yeah, look. Wow, that's incredible. They're just 3.25 light years apart. Look at the apparent magnitude there of Arcturus, 5.31. That really is incredible. And Arcturus is going to be in the skies of any planet. It would be nice to see a planet in this Morphrid system. So you've got the A star, which is a G-type yellow subgiant, and a red dwarf. So probably will all be planets in that system. And those planets will experience Arcturus pretty much day and night, actually, because it's so bright in their skies. So okay, I think we'll wrap things up there. If you want to see the next part of this list, just come up with some more interesting things here, types of stars, brightness and power. That sounds quite interesting as well. So if you'd like to see another episode of this type, let me know in the comments below. Look after yourselves, take care of yourselves and families, and I'll see you on the next one.